welcome back. So what we're looking at today is 6.3, similar triangles and other figures. So let's go ahead and jump right in. All right, so for 6.3, this first part, we are looking at solving each proportion. Show your work and check your solutions. So the first one we're going to look at is number 1. So we have a proportion, 3/4 equals x over 20. In order to solve this, we are going to cross multiply and then divide. So 3 times 20 equals 4 times x. 3 times 20 is 60, which equals 4x. Divide both sides by 4. 15 equals x. So cross multiplying, dividing, that is one way of solving these. Others of you might have noticed, okay, what do I have to multiply to 4 to get to 20? Multiply by 5. So 3 times 5 is 15. You'd get the same answer. So that method works just fine, obviously. Sometimes it'll be a little harder than others to try and figure that out because some of these will be a little more difficult. They may not all be whole numbers, so that makes it a little more complicated. But you can do that. The next one we're going to look at is 5. So obviously, things got a little more complicated. We have an expression now instead of just having the variable by itself. But we can still cross multiply and divide. So 3 times 20, well, we've already done that. We know it's 60. So 60 equals 4 times b plus 3. 4 times b is 4b plus 4 times 3 is 12 equals 60. So the first thing we want to do is subtract the 12 away. So 60 minus 12 is going to give us 48. So we have 48 equals 4b, divide by 4. So b equals 12. So that would be our solution. So be careful as you do these, but I think you guys shouldn't have much of an issue. All right, the next section, proving shapes are similar. So similar is your key word for this lesson, similar. Provide an argument to prove each conjecture or provide a counterexample to disprove it. All right triangles are similar. Is this true? Are all right triangles similar? No, they aren't. We could have different acute angle measurements. Just because one angle is the same doesn't mean all of them are the same. So our counterexample, counterexample, you can have different acute angle measures, such as we could have a 90, 45, 45, or a 90, 60, 30. Both of those would be right triangles, but they are not similar because the angle measures are different between the two. All right, the polygons on the grid below are similar. So do the angles all look the same? Yeah, the angles all appear to be the same. If we tested it out, we would find that yes, indeed, they are all the same, which means that this is true. Angles are congruent and ratio of sides the same. So the ratio of these sides is also the same. So between j and k here and j prime, or k prime, j prime here, they have the same ratio. Every single one of these, if we divided them, we'd find we multiplied by the same amount to get between. So that's another thing that has to be true with similar figures. All right. The next part we're looking at, a sequence of transformations occurred to create the two similar polygons. Provide a specific set of steps that can be used to create two similar polygons. Provide a specific set of steps that we can use to create the image from the pre-image. So we're going to look at number 16. So for 16, here we have these two polygons. So in order to take, let's see, this is our original to our new one. Sometimes figuring out translations, there's easier ways than saying how much you're going up and over when you have both figures. So we're going to translate all of this L to L prime. So translate L to L prime. So that'll move this all over here. Now it's still going to be facing the same way. So then what's the next thing we have to do? Well, then we're going to need to rotate it from K to K prime. So that way it rotates around, because obviously this is very much rotated. So rotate K to K prime. And then last but not least, we're going to have to reflect it. So reflect over LK. So those are a sequence of steps. All right, this last section, for each pair of similar polygons, give 3 ratios that would be equivalent. So we're going to take a look at this one. So 6 over A would be equal to 2 over 4, would be equal to y over 10. All of those are equivalent. We could do it for any one of these, but these would all work out to give us equivalent ratios because these are similar figures. So all the ratios of the sides need to be the same. So that's what you're looking at doing here. All right, if you guys have any questions, feel free to ask. Have a great day. Bye, guys.